Hey geometry peeps, we are here. This is lesson 5.3 and we're going to get into surface area of pyramids and cones. These are our last two solids that we need to learn surface area of, and we should have all the solids ready to be able to calculate surface area of our objects for our PBL after this lesson. So you should have that handout that I've given you in class. We're going to follow the same format as last couple lessons where I do a couple problems with you and have some for you to do on your own as well. Alright, so first we are going to work on pyramids. Pyramids will have a base. We can have different shaped bases, maybe a square base, maybe a triangular base, maybe a different polygon base, but either way, we're going to have that base, and then we are going to have our lateral surfaces come up to a point at the top. Now, we are going to still calculate lateral area, much like we did with our prisms. And we should notice that a cone or a pyramid is somewhat related to a cylinder or other types of prisms, except for now we've made them come to a point. Alright, so for a pyramid, we are going to need a couple different things. We are going to need our slant height, which is L. We are going to need our perimeter of the base, which is P. And we're also going to need our big B, which is the area of the base. Alright, so if I'm looking at my surface area formula, it says surface area equals 1/2 times LP, so slant height times perimeter, plus B, which is the area of the base, the bottom. So if I'm looking at number 1, I see that my base is this square on the bottom here, so I'm going to use my square formula when I am adding in my big B. Alright, so surface area is equal to 1/2, and I am going to need to use my slant height. So I can see there that my slant height is 11.7. So I'm going to have 1/2 times 11.7, so that's my slant height right here. So it's no longer the height, just perpendicular height of the pyramid. We are using the slant height, so that's why we have L instead of H. Alright, so 1/2, I'm going to have 11.7, and then I'm going to need the perimeter of my base. It is an 8 by 8 square, so I know 8 times 4, all 4 sides, is going to be 32. Right, so that is my 1/2 LP. So 1/2, L is 11.7, perimeter is 32. Then I'm going to add it with my one base at the bottom, which is my 8 by 8 square. So the area of that will give me 8 squared. When I work this out, I get 187.2 for my 1/2 LP, and then 8 squared is 64, and that comes out to 251.2 meters squared. So area of that pyramid, or sorry, surface area of that pyramid is 251.2 meters squared. Okay, let's check out number 3. We are going to skip ahead to 3 because there's a little bit more to do, so you know that means I'm going to leave number 2 for you. You should model number 2 just like number 1 here when we get to it. So number 3. Now the reason why I am choosing to do this one with you is because we actually don't have the slant height L here, which we need. We have the actual height of the pyramid, which is 3. And what we're going to use is the fact that we do have a little right triangle there where I have a unknown slant height, L. I know like my A is 3, and then I need to figure out my b. So what I see is down here at the bottom, I do have my square base, and this height is coming down right into the middle of the base, and then that bottom side is going to the edge. So that is going to be just half of my 16 wide square. So that will be 8 there. So I'm going to use Pythagorean theorem to solve for my L in this case, and then I'll be able to plug it back into the formula just like I did in number 1. Now I don't have to do this in number 2, don't worry about it, because I do have the slant height already given to me. Alright, so I'm going to do 3 squared plus 8 squared equals L squared. 3 squared is 9, and 8 squared is 64, and that comes out to 73 equals L squared. And rather than trying to simplify my square root and all of that, because I do want a number and a dimension to use, I'm just going to put this into my calculator. If I take the square root of 73, I do get approximately 8.5. Okay, so that is going to be my L that I use here, 8.5. Okay, now on to surface area. So surface area, I'm going to take 1/2 L times P, so the perimeter of my square at the bottom here, this square here, is 16 all the way around, so 16 times 4 is going to give me my perimeter, so that is 64, and then my slant height was 8.5, so I got 8.5 times 64, and then I'm going to add my base area, which is 16 squared. I do have a square base here. When I multiply that out, 1/2 times 8.5 times 64, I do get 272 there, and then 16 squared is 256, and so that comes out to, running out of room here, that comes out to 528, and I do want to do feet squared. Alright, so you know what to do. Number 2, again, don't worry about Pythagorean theorem, just follow the example in number 1. Alright, so should have number 2 done, and to check our work, the surface area for number 2 is 99 inches squared. 99 inches squared there. Alright, so we got some different pyramids now. This is a triangular pyramid. We do have a triangle base, and then in number 6 we even have a hexagonal pyramid there where we have a hexagon base. So I'm still going to use the same formula, so while I don't have the formula typed out like I do in the other one, I can recopy it over here. So I'm using surface area is 1/2 LP plus capital B area of the base. Okay, so number 4. This time I have my slant height. I do have that identified. So it looks like my slant height L is right here, 6.7. Alright, I have the perimeter of my base. So my base is this triangle in the bottom here. I know I'm kind of covering things up, but I do see a height for that triangle and a base, and I also have all the sides of that triangle. So it looks like for my perimeter, I should be taking 10 plus 10 plus 10. Okay, so it's like an equilateral triangle on the bottom there. So perimeter is 30. And then my big B is 1/2 base times height. And that's 1/2 little base. So my little base is 10. And my height is 8.7. So that's going to give me my big B there. So now I'm going to put them all into my surface area formula. So surface area formula, I'm going to take 1/2 L, so 6.7 times P, which is 30. Then I'm going to add that to my 1/2 times 10 times 8.7. All right, when I work that out, I get 100.5 right here, plus the area of my base triangle is 43.5, and that comes out to 144 inches squared. All right, and like last time, I am going to leave number 5 for you. This is an example that really models like what we just did in number 4. To help you out, we have our triangle down here. Looks like it is an equilateral triangle again, 7, 7, 7, and the height of my triangle is 6.1, and then I have my L slant height right here. So that should be everything that I need to do number 5. So make sure you pause and work out number 5. All right, and for number 5, we should have gotten 149.45 centimeters squared. All right, so let's do number 6 together. This one's kind of nice because they are already giving us the area of the space. It is a hexagon, and we didn't quite go over how to calculate area of hexagons, but definitely will need that, especially for some of our objects, so we will cover that. But nice thing here is that base area is just given to us, so we are going to follow our surface area. Looks like my slant height is over here. That's 11.3. I have my base, and then I can see that all the way around my hexagon here, I have those tick marks showing me that all the sides are congruent, and that's 6. So looks like it's going to be 6 times 6 to get my perimeter there. So perimeter is going to be 36. So I'm going to take 1/2 L, which is 11.3 times 36, and then I'm going to add that to the area of my base, which is already given to me, 93.53. When I work that out and multiply here, I get 203.4. I'm going to add that to my 93.53, and I end up with 296.93, and that is yards squared. Okay, now we're getting into cones. So that was pyramids, different bases. Now we have cones. It is very much like a pyramid, except for our base is a circle. I'm going to find similar formula here. So I can see in my surface area, I do have pi r squared. That's the area of my circle at the bottom. And then my pi rl is that lateral area, you know, that wrapped part that makes up the side of the cone. So I'm going to follow this formula here. So I got surface area. I'm going to take pi r squared. So pi times 7 squared. Then I'm going to add it to pi rl. So I have pi times 7 times 11.4. And when I work that out, you know, similarly to how I was working with my pi before, you know, I can put this all in the calculator with pi and combine it together. So I'm going to have 7 squared, which is 49 pi, and then 7 times 11.4 is going to be 79.8 pi. You know, I can actually add those together, kind of treat pi like a variable, and I end up with 128.8 pi, and then I can put that into the calculator, and that'll make sure that my rounding really only happens at the end. And when I put that in the calculator, I do get approximately 404.64 meters squared. All right, so number 8, leaving that one for you. Make sure we are using radius. So this is not radius, this is diameter here. We are going to need to convert it to a radius in order to properly plug it into our formula. Okay, so let's go over that one. Should have gotten, before the pi, you know, if I was practicing combining and writing in terms of pi, I would have 626.4 pi. And when I actually multiply that out, I get 1,967.89 millimeters squared. All right, and then our final cone example. Similar to the last one, you know, we don't actually have our slant, or actually we don't have our radius this time. So we have our height here, we have our slant height here, which is also 27.3 like the other side, but now we are missing our radius. So I'm going to use that Pythagorean theorem again. I have my triangle here like this, that is a right angle. If it's a height, I have 25.2. And then my radius is unknown, and then my 27.3 here. So I'm solving for A or B this time. So I'll say r squared plus 25.2 squared equals 27.3 squared. When I work that out, I'm going to have 25.2 squared. I got 635.04. So r squared plus 635.04 equals, and then my 27.3 squared is 745.29. All right, I'm going to subtract here. And I get r squared is equal to 110.25, and then finally when I take the square root of that, I am going to get the square root of 110.25, which is 10.5. So I got my r is 10.5. So now I'm ready to plug that in. I'm going to have surface area equal to pi r squared, so pi times 10.5 squared, plus pi rl. Remember, L is going to be the slant height here. So pi times 10.5 times L, which is 27.3. Okay, I work that all out. I get 110.25 pi plus 286.65 pi. Add my coefficients together, I get 396.9 pi, and that comes out to 1,246.9 inches squared. When I actually multiply by my pi, that ends up being my answer there. All right, just a couple problems left. Number 10, we have some applications, and we are given the surface area of a cone and the diameter. Find the slant height of the cone. So, you know, whatever it is that I'm given the answer, I really want to set up an equation. So I am going to use my surface area equation, but I'm going to fill in the parts that I know. I know that if I have a diameter of 18 centimeters, then that means that r is equal to 9, and then I have an area of 822.78. And so in my surface area formula, which is pi r squared plus pi r L. I have r, and I know what pi is, so I'm really just left with solving for L. So I have 822.78 equals pi 9 squared plus pi times 9 times L. Okay, so let's combine that together. I end up with 9 squared, which is 81 pi plus 9 pi L, and that's equal to 822.78. Okay, I'm going to, this 81 pi is really just a number, so I'm going to subtract my 81 pi. I can even put that into the calculator there for me. And that comes out to 568.31. That equals 9 pi L. And then 9 pi is again a number. I want L to be left there. So I divide by 9 pi. Again, putting this into the calculator. And I will get L is equal to 20.1 centimeters. Not centimeters squared, because I'm just getting a length here. All right, and then we got a couple problems left. I'm going to leave these for you because I'm trying to keep my videos a little bit shorter and sweeter. Finding the surface area of the figure to the left. I have a cone and a cylinder. And I want to pay attention to the fact that my surface of the top of the cylinder and the cone, it is hidden from me here. So instead of just doing 2 pi r squared, I'm just going to do pi r squared and only include the circle on the bottom. Hopefully you're able to follow that. If you have questions, let me know in class, and we'll talk soon.